Okay, we are live and I'm back. It's been a while. We haven't done this, so very happy to have Nate and Nahiko back with me today for a very educational session. Basically, smart contracts for dummies. We can maybe call it. We can call it that way. But yeah, how are you guys?
Good.
I'm good. Thank you.
Hoping we can make our way through this and be informative without techno babbling too much.
Amazing. Okay, so I'll leave it up to you both to get us started. I think we'll start with like looking at like Etherscan and just like understanding a little bit about what is it that we see when we look at Etherscan, and then maybe moving on to like smart contracts more specifically.
Sure.
Mm-hmm.
Cool.
Oh, I guess I'm already sharing my screen, right? Does everybody see it? Okay.
Yeah.
Oh, cool. Let's see. So yeah, just starting off, really, there are a few different block explorers, but the main one that everybody uses is Etherscan. So if you have never used Etherscan before, you can just simply go to etherscan.io /address, and then the contract will link you to any address that you need. I'm sorry, hang on just a second.
Oh, we lost him.
We lost him already. The first Etherscan.
That was too much.
Yeah.
Much to handle.
Sorry.
There you go.
I'm back. So anyways, yeah, so really the main tabs here are going to be the read contract and write contract stuff. The code, assuming it's verified, this is the CryptoPunks contract, obviously. All of the code, if you verify the code on Etherscan, means is that you take the source code and then you submit it to Etherscan, and then they compile it with the compiler you say that you used and whether you used optimization. And then it will take this source code that you push in and compile it down, and then if the bytecode matches, then that's how you can get a verified contract. So that's like one of like the magic powerful things about this whole thing, is that you can be guaranteed that this code does exactly what this source code does. And maybe you can't read source code, but you can trust or at least ask somebody who does know how to read it to tell you what's going to happen. There are plenty of contracts that aren't verified, and as for what those actually do, it's the only person who really knows is going to be the person who deployed it. So for the most part, you want to stay away from unverified source code. I know that goes against like the aping ethos or whatever, but generally speaking, I mean, NFTs are pretty low risk because you pay your ether, you get an NFT. It happens. It's not like a DeFi contract. You would never throw 100 ether into some unverified DeFi contract unless you. Well, I don't know why anybody would do that. So yeah. Anyways, so the source code will be under the code tab, assuming that they verified it. Write contract will have all the functions that publicly can be interfaced with. Read contract will have read functions that you can read publicly from the contract. So just for example, real quick, a really simple one. I mean, total supply is pretty obvious with CryptoPunks. There's 10,000 of them, but as these, I guess these were all pre-minted, but usually as a project is counting up, they'll be incrementing this number per the code here. This contract's a little bit different because it doesn't follow the ERC 721 standard. So there's some things that are a little different about it, I guess. But anyways, do we want to just like kind of walk through what each of these functions do,
Yes.
how it works, or is that kind of what you're thinking? Okay,
Yeah.
so,
Which functions would you look at first? Maybe if you
Exactly,
came to a contract and you wanted to get information, looking at this, which would be the first function that attracts you?
So, if we want to compare it to something that you're more familiar with, and this is making the assumption that people have used the CryptoPunks website before, I guess, but let's just say, shit, let me swap real quick. So let's do, dang it. Sorry.
In the meantime, Soft NFT is saying hello.
Oh.
Hi. He has
Hello.
a chain face as an avatar too.
Yeah. So this, so for instance, this contract, like if I wanted to list a punk, I would come to the website, offer for sale. I'd type in the price that I wanted to sell it for, and then the address that I wanted to sell it for, if I wanted to specify that. That same exact function, offer for sale, exists at the punks contract level too. So if the website were down, you could still list your punk. So that would be this one here, offer punk for sale. And then the other one, if you were to include an address, it would go here. So, the punk index would be, let's just say if I wanted to list this specific one, 1102. And then the sale price is in Way. So you would want to be careful. If anytime that you are using something like this, you do kind of want to know what you're doing, because if I wanted to list it for 30 Ether and I list 30, that would be in 30 Way, which would be.
So what's Way exactly?
What's Way?
Yeah.
It is a unit. It's a unit of Ether. So if you were to put it as 30 Way, then you would be basically listing it for this amount of Ether, which would not be good, because a bot would snipe it up before you even had a chance to notice that you screwed up.
And why does that work in Way?
So why did they have it this way? I think
is that common for?
So for the most part, most NFTs don't have their own built-in marketplaces. Punks is really, we settled on it because I think it's one of the most familiar contracts, but it's one of the most unique as for some of the features that it has that just don't exist anymore. But I think they did it for resolution purposes. When you do it at the website, it automatically does convert it, for you. Like, you don't have to, it says an ETH. So at the back end level, they take 30 and then they multiply it by 10 to the 18th, 10 times 10 to the 18. And then that converts it into the Ether price for you. So you don't have to worry about putting in the wrong thing. But I have seen, this actually is a good thing to mention. Where's it at? This accept bid for Punk. So I've seen a bot abuse this before. So somebody made an offer on a Punk. They came in here and they went to accept it. And then they didn't understand that this minimum price was in Way. So I think I want to say, if I'm remembering right, they put 5 for 5 Ether, but it actually was 5 Way that they were accepting. And there's a pretty complicated, sophisticated attack that you can do in Punks under the right circumstances. It's like, it has to be basically somebody screwing up and doing this. So, for example, somebody lists their Punk for 20 Ether, somebody offers 18 Ether on it, then that person wants to accept that bid, but instead of using the front end, they come here to the back end, or to the Etherscan interface, and they go to accept it with a minimum price that is far below what the actual offer was, because they used Way instead of ETH. And what can happen is a bot can overbid that 18, which removes the bid at 18. then they remove their overbid, and then they bid the amount that's this minimum price. It's hard to explain in words, I think, but
it's complicated as fuck.
yes, it's really a pretty sinister
Luckily, we said
attack.
this was going to be for beginners.
Oh God, I know. See, I was worried about this. Like, you can go off the deep end, you can go off tangents. Like, there's so many things. I mean, hopefully we get some questions and then we can kind of dial in what we're.
So wait, so I have a question already. So like many questions. So let's say, okay, so CryptoPunks is a very to the more of like the complicated contract end. What about like your standard like ERC-721 like contract? How would that show up basically?
Let's do look at autoglyphs real quick. I know it's not nearly as popular as CryptoPunks, but I think that for the most part, people at least know what it is. So, and there are still some excess. Well, actually, from the right side, this is a really simple contract. So this is standard ERC 2721 stuff. All that approved means is that another address can handle a token that you own on your behalf. So let's say you own token 100 and you want to let another smart contract, for example, OpenSea's marketplace contracts handle your asset. You can approve OpenSea's address here for that token ID, and then they can move that token on your behalf. There's also this.
So it means that it will show up in the OpenSea marketplace, and that it can be transacted on OpenSea.
So it means that it will already be on OpenSea's marketplace automatically. Actually, even autoglyphs isn't necessarily the greatest one either, because this key piece token URI is not implemented correctly. I mean, they did it this way on purpose, but they didn't do it the standard way. So it's a little bit different too. But
that's a good way to, for example, it's a good example because with this one, you can very easily verify that autoglyphs is fully on chain or to a certain point, just because as you just showed, when you look at the token URI, you can see the glyph. I think there's some arrangement missing maybe or something, but it's basically all of the information is already here, right? Or is that correct? Or?
So you have this, which is what a glyph actually is. Shit. So you can see that's what the glyph is, versus this was what, number 11, versus, let's see, so they do some processing here, which I don't think is a big complaint. They don't really exactly ever let out how or what the SVG conversion is and how they kind of prettify it or whatever. But my computer's going really slow. But so here's that actual glyph, number 11. It's like a basket of eggs, and then you got, this is what's actually on chain. So I mean, you have something that's pretty close.
Yeah, it's basically just a typography thing, right? Because maybe it's bold and the space between characters is bigger or something.
Yeah, this is pure ASCII, and then this is an SVG. If you wanted to just see what that looks like. Well, it's not one to wrap the line, but
so I think it's a good example just because, for example, for a regular NFT like on Rarible or whatever, this function token URI this is the function where you basically get the IPFS link usually, which everyone knows about, which is the file that's on IPFS, not fully on chain but still decentralized, blah blah blah. But in this contract, you can see it's, for example, it's you get the actual file more or less. We can talk more about it, but there's a lot more information for sure. And then you can still implement another function to like get an IPFS file, which would be the representation of this, for example.
Yeah, I think whenever I think about like the first on-chain art piece, I think that this still qualifies, even though technically they didn't follow the ERC 721 standard, where this is supposed to point to some. It's usually a link, but ultimately the goal is to point it to some JSON that has all the information that's needed to populate an OpenSea's interface, which is usually an image and some metadata.
And what about, like, as you were saying, Nahiko, a standard Rarible or like OpenSea contract? How does that look? And what will that, the same, like here it generates, because it's on chain, it generates exactly what like as similar as possible to what the autoglyphs look like. With when it's stored in IPFS, how does that look?
So basically you would, so I don't know if you're going to show it, but basically you would have on this exact function token URI, if you input, so usually a function is you give it input, it outputs something. So usually the input for a token URI is the token ID. So if I have token 45, I don't know, I should see my token or the informations of the token, like the title, description, etc. So in autoglyphs, you get just the ASCII characters. In a regular ERC 721, you're going to get a link to an IPFS file, which is a JSON file, which contains the title, the description, the amount of tokens, I guess, and the link, another IPFS link, which would be the image or the video file or whatever file it is. So it's decentralized, but it's IPFS. Like, it's not completely on chain. It's still relying on something else than the blockchain.
Yeah, so normally it works more like this. Whenever you go to the token URI, there you input the ID and then you get a URL. And that can be stored on IPFS. Some people store it on a server, which is not ideal, I guess, or sort of these like serverless function type things like Azure, or I can't remember the other one that's kind of popular. But anyways, the goal is that you store this information here. So your metadata, so this is a JSON, just as what's it called? It's just as a way to package your data. So it has the image here, which for this one, this is an SVG that's on chain. This entire thing comes from the function that's on the contract. So this isn't a typical way of doing it either. So we're still really in the weeds here, I guess. But OpenSea knows how to look at this and say, okay, that's the image, that's the description we're going to put underneath it, that's the external URL, that's the name of it. These are some attributes attached to that will make metadata stats or whatever, if you will.
Okay. And so going back to, I guess, more like basic questions. So let's say that like, somebody is looking at Etherscan and wants to know who is the creator of the token and where is it hosted? Where do they go and see it?
The creator of the token. So
yeah, like the artist per se.
I got you. It depends on the contract. If you're the one writing the smart contract, you kind of choose what you're going to put in there. As far as what's in this, there's not a whole lot of real like hard rules. I mean, really the only rule, there's this idea of being able to approve it. There's this transferring function. There's this set approval for all, which we talked about approval earlier. Set approval for all is what you actually do with OpenSea, and you basically just tell them, or you basically are letting the NFT contract know that this address can move all of your tokens on your behalf with a signature, with whatever initiator you need. But like if so that's a key piece. A lot of NFT projects will have something like this. So let's just say the Bored Apes would have had create ape or make ape or whatever they called the function. You pay the ether, and then there's some random seed here that in this case it ran through on-chain RNG, which is not ideal. But let's go. Shit.
We have a question which says, what is the function that creates the NFT?
The function, so there is an internal function. Usually the way people, so here when you go, so actually, yeah, this is a good question because I can sort of show how it would actually kind of work or whatever. So let's go back here. Let's pretend that we're going to create a glyph through Etherscan. On their website, it would just be a button probably, and you click the button, and then their website code prompts your MetaMask, and it also probably populates this seed for you. And then all you have to do is submit the transaction. That's the way that it usually works. But behind the scenes, what actually happens is, well, yes, you still pay the ether amount, and then you put in a seed, and what it would look like is create glyph with that seed. And all they're doing here is calling this mint function. Usually the mint function is what actually creates the NFT. What they did in autoglyphs is they did all this logic in the mint function. You usually don't do that. I mean, it's not necessarily wrong, but usually that's just not the way it's done. I think, for example, who knows? I probably did some weird shit on this too, but usually people don't do that. So yeah, so here just mint. The mint function is just the standard mint function. It's basically saying don't send it to address 0, make sure that it doesn't already exist, and now send it to the person who called the mint, or the person who's supposed to get it. And then all the logic exists in.
And just before we dive deeper here, I think there's one point we didn't, I mean, you did talk about it, but really quickly. So there are basically public functions and private functions. I mean, it's a bit more complicated, and so basically the mint function is private. So it can only be called by another function inside the contract. Like you cannot go to Etherscan and call the mint function, or at least this one. So you call the create glyphs, which calls the mint function.
Yes. Yeah. So again, you see.
So wait. Let's take a bit of a backward step here. So there's public functions and private functions. Can we explain these two and what is the difference between them?
Yeah, I mean, so really the difference is just public. There's public, there's external, there's internal, and there's private. Let's see if I can remember this exactly. So public can be called by a contract. It can be called by it can be called by anybody. External can't be called by the contract itself, but it can be called externally through another contract or through a user. Private can only be called yes, private can only actually internal. Let me do that one first. Internal can be called by the contract itself or by derivatives of that contract, but it can't be called by like an external address or a public user. And private, I think that private can only be called by the contract itself and no derivatives. I'm actually Not 100% sure on that one.
So for example, let's say that somebody, so a private function in this case would be like to mint a CryptoPunk, like for somebody external to mint a CryptoPunk.
Let's see.
Or not.
So a private function. Let's see. So here, Nahiko mentioned it earlier. This mint function is internal, which means that if you come to this write contract, you don't see anywhere to mint, right? The way that you would mint a glyph would be through this create glyph function. So internal still means that this contract can do it whenever this function underscore mint gets called, which happens here. It's happening because a public external person called create glyph, and then the logic inside create glyph called the mint.
Okay. But that's usually because, so correct me if I'm wrong, Nate, but I think that's, so basically usually mint is the standard ERC function. And if you want to put like a specific logic, you're going to try to avoid changing this function just because it's standard, and you're going to put it inside the create glyph function, for example, saying like the user needs to have a specific token to be able to mint or something.
Yes. Yeah. Usually you would do, so like inside this, under this internal function, usually this logic would all live at the create glyph level. And then the very last line of create glyph would call this mint function. And it would do these require statements to make sure it's not getting sent to 0. It doesn't already exist or whatever. And then all it would do is just mint it to that address. But not that there's not really a right or wrong way to do it necessarily. I mean, if it works, it works, but usually that's how people will do it. In here, all this logic for creating a glyph exists. It's pretty complicated if you don't know how to read code, which I'm assuming that would be more like advanced stage stuff. But when somebody was asking how you get from, how does this create this NFT? The answer is that it calls that create glyph function. It calls this mint function. This mint function actually calls a number of other functions. So you've got the biggest one, I think, is draw. Damn it. Yes, here. So this is sort of the algorithm for a glyph. The randomness starts here, and it's derived by running this out or running this RNG algo on the ID itself. So, or no, actually that's not true. There's ID to C. I'm trying to remember how this works exactly. Ultimately, A is just a random number that you get whenever you mint. This is called inside that mint function. And then they take that letter A and use that as a source of entropy for this whole thing. It runs this giant for loop here. Where's it at? So this first for loop is that. Where's the other one? Oh, here it is. This is a nested for loop, and it iterates through. We're probably going too far in the weeds on this one. I mean, we could talk through this, but it would be, this is not beginner level stuff. So
maybe what are your questions? Maybe you're our best guide here.
Yeah. So I think my questions are very basic, to be honest. So this is like, complicated stuff. But my basic question is. We actually have a follow-up question. Wait. So the actual mint function that creates the token in the blockchain is a standard function?
Usually, yes. It's part of the ERC 721 standard. So, again, and it just came from a library. Like I didn't write this code for minting. This was just part of the ERC 721 standard, which if you
Now you're gonna have to explain who
Yeah, what is
unsettled are.
Oh God, I know. No, I'm just going to show this. This is, for better or worse, boilerplate code that you can use for all your ERC 721s. This handles some of the this will not make you like, you can't just take this code and just deploy it and then there your project is done. You still have to write the logic for everything that's unique about it. But this handles simple shit like the token name, the symbol. It handles how many somebody owns. That's what balance of is. It handles who the owner of a given token is. It handles this token URI function, which you have to tell it what to output still, but it handles at least.
Can you send me the link to this in the chat so I can link it in the comments on Twitter?
So
Great.
basically, the idea with this is to not reinvent the wheel, right? The idea is that this has been validated by enough smart people that it's robust and not easily, at least, exploitable. And whenever you take the risk of programming your own shit, or sorry, the more you program on your own, the more risks you introduce, right? I guess.
Yeah, I think that's a good way to think about it. Think of them like Lego blocks that already exist, that people have they're tried and true. You've got shit like this. You've got libraries that have existed for, months or years that have been used, a ton of times. You don't have to figure out every little key thing. So let's just show this. I know this one because this is one that I deployed. Literally the first, I'm still, let's see where it starts. Like the first 1,000 lines of code. I had to grab the stuff that I needed, the Lego blocks that I needed to use. But down to, this is where it starts with me. So at 1219, the first 1,216 lines of code on the squiggly contract are boilerplate stuff or libraries. This is a library, but this was custom. This library is custom. That library is custom. And then the contract, like the squiggly contract itself, is from 1,400 to 1,800, 400 lines of code. So, yeah, you still have to write your own code. It's not going to just work without, like, you can't just put all the Legos together. You still need something, because you're trying to do something with your NFT. So you still need to program what that is. Like this contract might be a little bit, it's not as well known, obviously, but it's pretty easy to follow, I think, because actually, no, even this one has some really weird shit in it too. Let me go back just a little bit. I do want to talk about how to do this at the read contract level. So, because this is very crucial and like core to NFTs. So like the owner of a given token, if you want to know what that is, if you've ever wondered how OpenSea knows who owns it, that exists at the contract level, and you can come here and it will tell you who owns this C35 is the punk's address, the punk dev's address. But it will tell you the owner of any of those addresses. You can come to these functions, and as long as you input a valid input, so like you can't do 600 because there's no token ID 600 for autoglyphs. But as long as you input something valid, you will get a valid owner of that token ID. The balance, this is Nick, I believe. He owns a shitload of glyphs. Yeah, 56. But you can look up the balance of any of the owners. You can look up the developers. Okay, so they also kept up with the creator of tokens. So I know this is me because I created the last one. So it still keeps up with that. Even though I don't own this token anymore, it knows that I was the creator of the last autoglyph here.
And so will it also know who were all of the previous owners of that single token?
So you could program it to do that. This one knows who, so with autoglyphs, the creator was the first owner. So you can look up who the first owner was of any autoglyph. I think I did this one with an alt though. So yeah, so you can let's just take a random guess. Probably would hit pranked in here sooner or later. Nick again. So yeah, I mean, you would see. You can see who the creators of all these tokens were by just checking the ID here, querying it, and then getting an address back. That's not necessarily who owns it anymore. So even though I was the creator of 196, the current owner is this guy. If you were to get his address.
So for example, with autoglyphs, because they're auto-generated, so like every creator is unique in a way. You can see who created it initially and who owns it, correct?
Yes. Okay. So you can see, sorry, keep on.
No, good.
Yeah, so like I think for the most part, it's rare that you actually have to use the back end here. I mean, I can show another way that you can interact without even doing that. You can do it by doing custom hex data. So you can put in the hex data here, and what actually happens when you send a transaction, it's really hard to keep this. I mean, this stuff is just technical inherently.
So much stuff, yeah.
I
was going to say, let's talk about gas, and then I realized, no, this is another shithole. Like, too much to say.
So when you send a transaction to a smart contract, all that happens is that usually the website does this shit for you. It makes this hex data that the smart contract can understand. So I know that nobody really knows how that works, or most people when they're using it have no idea how that works. What it is in this case, this is the function ID that would map to, in this case, it's looks like this is a set approved for all, I believe. Yeah, set approval for all. So that method ID is how the contract knew, hey, he's calling set approval for all. And then it required two input parameters, one being the address, the next being, yes, I'm approving it, which is a 1 for true, or a 0 for now I don't want to approve it anymore. Now it's false. But really what you have, all that happens is your wallet is sending this hex data. There's the address, there's the 1 for true. And then this would be, again, that function ID. Let me actually go back, because if you go to the last page where, shit. Okay, here where people started minting. Here's me. So whenever I was minting, I was using the website, create glyph, the seed was in there, the method ID, but all that happened was it was calling the create glyph function, and then this was the seed, which was generated with the website, which is.
And the seed determines the token?
In this case, the way that they took this seed and then they run moduluses on it in a bunch of different ways, and they get the remainders, and that's how they can determine what the class would be. And I guess ultimately the design too, but yeah, and this is actually why you can abuse, especially with this one, it was pretty easy, because you could technically have deployed this in parallel, ran seeds against it, and looked for ones that were going to have scheme 9, scheme 10, and then only ran those seeds through the back end here. You could have came in here and said, if you use their front end, they were doing it randomly, but you could have came in here and told it any seed, seed is going to give you a scheme 10 or whatever.
And what about like a very standard, like smart contract, like for example, what an artwork has, like on Rarible or OpenSea or Super Rare?
So for something like that, let's see. I mean, we can just take a look at one. That might be the easiest way to do it. So now we're jumping around a lot. It's just as a complicated subject. I mean, it's hard to really stay on one tangent. Like if you don't have any depth into it, it's hard to get anywhere. Really, what happens when you create a super rare token is their backend pushes this information directly to it. So whenever, let's see, I haven't looked at this one too much. This is new for me to look at, but it must be one.
I think it's add new token. No? To mint.
Oh, yep. Yeah, you're right. Yeah, that's what it'd be. So looks like, yeah, they're just putting the URI in as a string, which in this case comes out the other end as, this IPFS URI. So, and then this, you can see the image here is also stored on IPFS. So then if you were to take it another step further and see what that was, then that's the first image. That's token one. So, I mean, that's all they're doing is pushing that information in at the right level, and then on the read side, pulling it right back out. When
you can see who is the creator of this. Like, can you see the name of the artist, or can you just see that it's been minted on like super rare and these are the owners?
I would guess for super rare, okay, yeah, they do, the creator of token. But this is not a standard thing. You don't have to include who the creator of the token is. Yeah, I mean, Autoglyphs did it. I think that I did it with both the NFT projects I launched. But you don't have to do it. It's not part of the standard or anything like that. It's just something that I personally thought was like a kind of a cool thing to know, and some other people do. I think with like an art contract like super rare, it makes a lot of sense that you would always want to have that sort of history, so they would do it. But whenever,
maybe you can show how you could you can look at a specific token, like filter, and then you can see the history basically on the blockchain of this token instead of calling the function.
Oh, okay, yeah. Let's see.
So if the function is not implemented, you can still trace where the token's been just by looking at it.
Oh, yeah. Okay, yeah, through its transfer history. Let's see. So yeah, here's
it can be useful sometimes.
Yeah, so you can actually look up the query here is the contract, and then question mark A equals, and then the token ID. This is an autoglyph still, token 196, which it got created 800 days ago, transferred to me. Looks like I sold it 257 days ago, and then 159 days ago, that person either sold it or retransferred it to this person. So now,
can you see how much it was sold for? Yeah. Okay.
Yeah, here you go. So this was 12 Ether. My guess is that the person who bought it probably didn't resell it. They probably were just transferring to like a new wallet.
So, for example, like obviously, like all of this you can see as long as the token is transferred on the chain, right? Like that doesn't happen all the time. Like a token can be transferred and you cannot see all of this information, right?
No, it would, assuming that they've implemented 720, their NFT standard correctly, then yeah, this will always show up on Etherscan. You can always see the history for in any token. So, number 200 was bought by Nick, and he never sold it because he never sells anything. 300 also bothered. Try a different one. Okay, so this one's moved around a little bit. Minted to pranked. Pranked sold it to.
How do you know all these by heart?
Yeah.
I can just recognize the addresses after seeing them for a while. So like, yeah, and he, if you go through Prank's history with autoglyphs, you see he's got 138 transactions with autoglyphs because he minted a shitload of them, day one per his, usual MO. And then, started selling them, obviously, per his usual MO. It looks like Jim bought a number of them. I think this is Snowfro buying. But anyways, you can see the history of any of these tokens because assuming that it was implemented correctly, yeah, I mean, you can see how it's bounced around through these addresses.
And a question for Nahiko, like, what is it that you go and look at if you're looking at a smart contract? What is the first thing that you look at? Not if you want to, like as a norm, not to exploit it, just as like a standard.
So yeah, I mean, I don't even exploit smart contracts that much. I tried once, or twice maybe. I'm more of a front end guy. But yeah, I would look at the token URI just to know where it's hosted, the image, because yeah, as Nate said, like I said earlier, it's an IPFS link, but sometimes you see, I think one of was it the squiggly one, or I can't remember. Sometimes it's just hosted by the people themselves, like on a server or something, which is okay too. I mean, at the end of the day, my opinion is the buyer should take care of the artwork. But let's not dive into this. The token URI function is really interesting. Then I like to look at not only the contract, but the token history and like where the token has been. If I don't know, for how much it has been sold, or what the functions are. The interesting thing is the reading functions. So you saw there are two tabs, right? There's read contract and write contract. I think it's self-explanatory, but read contract is basically reading the information that's contained in the contract. So like, who's the token owner, what's the IPFS link, whatever. And then write contract is like actions, like minting, transferring, whatever. So whenever you want to do a write action, you have to pay gas, and it's a pain. Like, you take the risk also if there's a revert in the function, like if for some reason there's an error in the function, you're gonna have to pay gas and not have anything at the end. But read functions are free just because they are not actually, they don't write anything on the blockchain. They just do it locally on the OpenSea, on the Etherscan side, and just send you the result. So it's like, this one is free, so you can abuse reading contracts and like looking at the balance of whoever this person is, or it's the good thing about transparency.
Yeah, one thing I do want to touch on again. So with like the token URI, this just being like the way that they are doing it, I think, generally you don't like the goal would be to not have any centralized agents in your NFT. But I think I sort of like, so with Squiggly, for example, I'm bringing it up because of that one, because one of the, I think, strengths of that project is that the art and the metadata are 100% on chain, but the way that the information is served over to OpenSea is through an Azure like serverless function. So I think that it's still okay that it's like that, because if for whatever reason that Azure went down, Microsoft tanked and they pulled that Azure down, you can still update the URI from the contract, which still wouldn't be ideal, but all the information for this does still exist at the contract level. So anybody would be able to pull the information and then resubmit it over because, here you've got the full SVG, you've got the creator of it, you've got, well, you got a number of other things, but you've got all the metadata here available. So, I mean, all this stuff is still here to be able to recreate this if for whatever reason that sort of middle service between OpenSea and this contract were to go down. With like IPFS, you don't have that unless you as a user have saved the image yourself and have another way to push it up in the instance of IPFS failing. Whereas here, this would take Ethereum failing for you to actually lose it. If that makes sense.
Yeah, that makes sense. And what if, as Nahiko was saying before, how do you recognize if something is partly or fully like centralized to a server and not even on chain, not on IPFS, but just centralized to like a single server?
The easiest way to see, so for the most part, you're not going to see like even
it's not an easy answer.
Yeah, you kind of have to know what you're looking for a little bit. I mean, I think that even with hash masks, they did not have a token URI. Yeah, but they did push to IPFS, and then there's some way that hashes into this. Let's do Bored Apes. Everybody's.
Maybe we can look at fade too from Pack, just because it's I mean it's a bit like squiggly. It's an SVG.
Yeah. Let's. What's the easiest way to find it? Just side of the easy thing.
If you type fade Etherscan, I think you're gonna find it.
Oh really? Okay.
I guess.
I think that's it.
0x7 EC. I think that's back.
You think this is it?
Not a stalker.
Let's see.
No, probably not.
I know that I can find it this way though. So instead of these auction, you can take a look.
It's interesting because it's recent. So there's a whole lot of like processing that's done inside the contract. Maybe we don't need to dive into this, but just when you call the function, you get an SVG file. You just paste this in your browser, and you see like the image that's displayed, for example, on Sotheby's. Like it's quite simple to verify.
So is that at this token URI level?
Yeah, exactly.
Oh, okay.
You have the SVG directly, but you could sometimes, as Nate said earlier, sometimes you could infer the SVG or whatever the file is from data that's inside the contract. Like you could have. I'm not going to go into detail, but too much. But for example, if the image is just black and white pixels, like 2 by 2, you could just have bits of information like 0101, for example, and know that this is the final image is 4 pixels, 2 by 2, and then recreate. You could write text somewhere in the contract saying this, and then that the person reading this can recreate the image themselves. Like technically, it's on chain, even though you don't get the image with the result of the function. You know what I mean?
I think so. This is some, yeah. I mean, it looks like for their token URI, I don't know. We can look in here and I can try to see if I can understand how they. Oh shit, that's gonna be.
I tried, but it's I was too lazy.
Yeah, there's this would take. I mean, it looks like there's a lot of probably references to other functions here. There's several contracts.
And just to explain why we mostly talk about SVGs here, it's just because it's easier to create big images. SVGs are basically vectors. It's easier to create big images with vectors because you need less information. For like basically Ethereum is not made to contain data. So the maximum amount of data you can put in one variable is basically 256 bits, I think, Nate, right? Correct me if I'm wrong. But it's basically, it's very difficult. Like you couldn't have a 1080p image fully on chain without paying like thousands of transactions and like having everything parsed in the front end. But SVG
Yeah.
files are very easy to
Efficient.
navigate.
Yeah. Yeah. I think
So
that's
sorry, what makes this contract and the way that they deployed it with Sotheby's, let's say, not special, but kind of like unique? Maybe Nahiko, or Nate.
So I don't think it's unique. I mean, it's unique just because it's a unique project, right? But there are many on-chain projects. I thought it was just a good example because it's recent. But they do, I think they use like wallet information to influence how the SVG file will look.
So it looks like it's ever changing. Even this is the SVG that's coming out. So even without any of this data changing, there's some sort of
animation or something.
Yeah, here something. I don't know enough about animating SVGs to know exactly how this is working, but there's some sort of rotation, indefinite. I mean, this is and then there must be some sort of color changing piece in here as well because the color is changing too. But you can see it rotating. The white spots here, and it's rotating clockwise. It looks like.
And you see, for example, to create this image, you only need to like say it's a circle, and then there's a gradient. Whereas if you would have to use like an image, like a JPEG or whatever, you would have to tell the computer, okay, this pixel is this color, this pixel is this color. Mm-hmm. That's a lot more information to put on the blockchain, and that's just too expensive. It's technically doable. Like you could have like 10 contracts with I don't know how many variables containing all the IDs. And I think I calculated at one point, you would need like to pay like $30,000 just in transaction just to put your image on chain, and then you would have to parse it in the front end. So like
somebody's saying you can see the transfer duration towards the bottom of the SVG.
Yeah. And I think the idea for this artwork is it fades away until it's transferred to someone else or something. So there must be somewhere an opacity setting that depends on the time between today and the date it was last sold or something. I saw that on the Sotheby's side, which is an interesting concept, right? And that explains the fade.
Yeah, if they're building this dynamically, then there might be some sort of interaction here, like say upon a transfer, it changes some variable in here, which affects the image in some way, even though that doesn't exist at the SVG level now. But the contract itself is what will say repopulate all of these variables, or repopulate these, or repopulate this length here. And yeah, I mean, this is an interesting way to do it. I think the first time that I saw that was the Uniswap NFTs, which I like immediately had to like do a test on it, and it wasn't working. So there was some sort of coordination with OpenSea here, but instead of the token URI pointing to a URL that gave a JSON, like kind of the idea that people started coming into was, hey, what if we just put the JSON directly at the token URI level, and then it doesn't have to point anywhere. The contract actually has that. You don't need that external middle site or whatever.
All right.
But you couldn't put like the image we saw, which was an artwork by Robbie Barra. You couldn't put this in an SVG file without it being too big anyway. So you wouldn't be able to do this type of artwork for like regular, quote unquote, regular digital art. It has to be somewhat simplistic or clever.
Yeah, and I think so. Like even let's just say Avastars, you've got this SVG. I mean, you can see it's pretty bulky. I mean, this is 40,000 characters, but that compared to like even a simple PNG is still far below. So that's why, with something like this, you can, with SVG, I think you can, it just is so optimized that you can do a lot more in terms of like storing something fully on chain versus really any sort of PNG that has any kind of resolution and a shitload of pixel colors and that would just be impossible. Well, not impossible, but it would just cost a fortune to store something like that.
All right. So I think we covered quite a few things. We'll probably have to, do another of these practical sessions because I think there's more. And maybe we can get probably we'll get some questions afterwards. I might get some DMs for sure. So maybe we can cover more of that next time.
Yeah. I mean, we can try to maybe be a little more coordinated with it. I think it just is such a broad topic. It's really hard to know. I think like the easiest way to like understand it is if there's a contract that you understand fairly well, like what functions you can do from the front end, what information you're used to reading back at. If you go to that contract's address and you look through the read functions, you'll recognize some of them and you'll be able to understand, okay, I input this data, I get this back. Okay, I understand that. And then even at the write token level, I wouldn't recommend writing, like you should probably know what you're doing or at least ask somebody what you're doing. So that way you don't get in a situation like listing your CryptoPunk for 30 way. Like that would be terrible. So
I lost a lot of money trying to hack stuff.
yeah. I mean,
just with gas.
Yeah. And yeah, as far as reverting, you can see really actually if you try to push through a function as a write function and you put in bad data, MetaMask usually will flag it. It will show you that 11 million gas or whatever, where it looks like it's going to fail. It's going to cost 2 Ether to send it. That probably means that you've got a bad input, but you still could accidentally, and again, with the instance of CryptoPunks, you could accidentally list your punk for 30 way if you had no idea what you were doing. So
maybe next time we can speak about gas and way and gwei and all of that.
Yeah.
I also have some examples of exploit with gas. That could be interesting.
Oh, amazing. That would be cool. All right. Well, thank you so much, both of you. And we'll see you next time.
All right. See ya.
See ya.
See ya.